Here's section 2.5, theorem 2.5.3. And here we're getting a very nice theorem as to when at least 2 by 2 matrices are singular or non-singular. So well, actually their theorem only goes the one direction. So they say let A be some 2 by 2 matrix, A, B, C, D, and delta, uppercase delta, A, D minus BC is not equal to 0. Then A is non-singular, and now I'm adding this, they put this kind of in the bottom, but and A inverse is equal to 1 over delta times D minus B minus C and A. So there, if the determinant is not 0, then A is non-singular. And but notice they don't actually go the other way. They don't say, well, if A is non-singular, then that quantity will not be 0. But that is true. And so in our proof, well, pretty much we can, to do this proof, we can simply multiply by our candidate A inverse and show that we get the identity. Okay, so let's try A inverse times A, and that's 1 over delta D minus B minus C A, and then times A B C D. And so that's that scalar 1 over delta times, well, we get AD and minus BC, and then BD and minus BD, that's going to be 0. And then down here in the bottom right, we get a minus AC and a plus AC, that's 0. And we get minus BC and a plus AD. And so this is 1 over, and remember delta was AD minus BC, and this is times AD minus BC, a 0, and an AD minus BC. And so multiplying through by the scalar, we get 1, 0, 0, 1. And multiplying on the other side, you know, A inverse works similarly. Now notice, see, if this AD minus BC is equal to 0, we cannot multiply, or, you know, well, we can't multiply by 1 over delta. Okay, 1 over delta is undefined. And so, because of this nice property, we call delta equal AD minus BC, the determinant of A, our matrix A, because it determines whether A is singular or non-singular. And so that's a very nice theorem there. We can do a quick calculation of this AD minus BC and tell whether something's singular or non-singular. So let's look back at that example, the previous example with the matrix A equals 1, 2, 4, 8. And notice that the determinant here, delta, is equal to 1 times 8 minus 2 times 4, which is 0. So A is singular. So that's a nice little tool right there.